20% of all wastewater in Denmark, because we're in the capital, of course. So we are going to have a helmet and a vest, and then we will take you for a tour. It takes approximately 1 hour. It will be my colleague Carsten who leads the tour. He's very technical, so you can ask him all the questions. Please don't ask me. Oh yes, you can also ask me, but I'm not as technical as Carsten. So please follow me and we will accommodate you with a helmet and a vest.
Treats the wastewater and rainwater from the central Copenhagen area and also some of the other municipalities around Copenhagen. The design capacity is 1 million personal equivalents, and if we look at how many inhabitants there are in the area, there are around 550,000 inhabitants, but there's also, of course, wastewater from industry, and if you look at the total loading of the plant, it's around 1 million PE, so the plant is fully loaded. There are 3 inlet pipes to the plant, and all the incoming rain and wastewater is pumped out to the plant. You can see the inlet pipes here. There's one from the northern part of the Copenhagen area, and there are 2 pipes here coming from the southern part of the Copenhagen area. Is 41,500 cubic meters an hour. It is a combined sewer system, so all the rainwater and wastewater ends in the same collection system and is eventually pumped to the wastewater treatment plant. So there's a huge difference between the dry weather loading, if you look at the hydraulics, and the wet weather loading. Go back, look at the energy production in the biogas tanks, the digesters. Come over here. Okay, the first steps of the treatment process is a traditional mechanical treatment. We have screens in the building there with the square round windows, 8mm screening installation, so every particle above 8mm is withheld, and it's dewatered and transported to an incineration plant for domestic household waste. And here we have the grit and grease chamber, where we take out as much fat than we can from the incoming wastewater. The grease is pumped over to our digesters, where we produce green biogas we export to the city. More of that later. The sand falls to the bottom of the tank, and it is washed and it is reused for road use. Okay. After the grit and grease chamber, the wastewater is divided into 2 streams. We have the primary settling tanks here, where we have a retention time of around 1 to 4 hours, depending on the hydraulic loading of the tanks. And here we want to take out as much as suspended solids as we can, because there's a lot of organic matter in the suspended solids. The suspended solids is taken out of the tank, pumped over to the digesters where we produce biogas. Well, we try to think circular economy in what we do in Biofos, and actually we try and have a strategy of being energy positive and have an energy positive treatment plant. This is not just this plant, but all 3 treatment plants we operate. And actually since 2014 we've had a positive energy balance. So actually we produce much more energy in the incineration plant and at the digesters, and we sell more energy to the grid than we buy from the grid. So actually now we have a positive energy balance of 178%. So every time we buy 100 energy units, we sell 178 energy units to the grid in form of district heating, electricity, or biogas that goes to the city gas grid.
Is this the biogas output? It's something really important?
Yes, the biogas is really important for us. And actually, if we look at the municipality of Copenhagen and the biogas grid there, and I think that around 30 to 35% of the biogas used yearly comes from the Lynetten plant.
Sorry, could I just kind of ask you, is this a kind of role model that could be reflected and branded and exported from Denmark, that from wastewater you could produce biogas?
Yes, of course. You can produce biogas if you have digesters, but then you of course need to have a system so that you can perhaps export the biogas to a district biogas system. Then, or if you don't have such a system, you can convert the biogas to electricity in the biogas engine and produce electricity and heat. But of course there's a loss in when you change from one energy form to another. But I think we are at Copenhagen at our treatment plants very fortunate that we can deliver both electricity and district heating and biogas to the grid.
Did you have any delegations from the world?
Yes, we have also delegations from other countries.
Have they did that somewhere else, like using your model? Or
I know that on a lot of plants they produce biogas. That's not just in Denmark, but all over the world. And I think it will be more and more common to utilize the organic matter in the incoming wastewater for energy production. And wastewater treatment plants will not be just wastewater treatment plants in the future, but resource recovery facilities. It's okay to come closer. So we are at the end of the primary settling tank, and the water that goes to the next step of the process flows out on top, and the sludge that has settled is pumped to the digesters. And if we look at the efficiency of the primary settling tank, around 50 to 60% of the suspended solids here is taken out as sludge and is pumped out over to the digesters where we produce the biogas.
Anyway.
Okay, from the primary settling tanks, the water flows through some anaerobic phosphorus release tanks here, over there, where we actually start the treatment for phosphorus. And after the wastewater has come out of that tank, it's pumped in our intermediate pumping station here and lifted a few meters, because you can see that this part of the plant is built a little higher than the old part of the plant down there. This is where we have the nutrient removal, where we treat the wastewater for nitrogen and phosphorus. We have nitrification and denitrification process, a biological process. And we also have biological phosphorus removal. We try to optimize the operation of the plant, so we treat the water as best as we can with low effluent values and with as little electricity used, and with a little chemical, as little as we can chemical use, because the phosphorus removal, the biological phosphorus removal, cannot get down to the low levels that are in our discharge permit. So we have to use some chemicals, iron chloride, for chemical precipitation of the phosphorus. But around 75 to 80% is biological phosphorus removal. This part of the water treatment plant is operated with a process called Biofos. That's an alternating process. So you have two tanks run together, where you have denitrification in one tank, you have denitrification in this tank, and nitrification in the other tank. So here we convert ammonia to nitrate, and then the water flows through some holes in the wall there to this tank, where we have the denitrification, where nitrate is denitrified to free into gas that evaporates to the air. In the aerated phase here, phosphorus is also built into the bacteria. So actually this is how we have the biological phosphorus removed. Øresund.
Thank you.
industrien i København, det er jo etableret lige efter det sidste kopperepidemi i 1950. Here, and the treated water comes out of the settler and it goes to Øresund. Here you can see our 5 digesters where we produce biogas. It's not just the primary sludge that's pumped over to the digesters, but also excess sludge, excess biological sludge from the water treatment taken out of the secondary settler is dewatered and pumped into the digesters. And on a yearly basis, we produce around 8.5 million normal cubic meters of biogas. And of that amount of produced biogas, around 6 million cubic meters is sold to the city gas grid. The rest is used for internal purposes on the plant, for starting up the incineration plant. When we have a maintenance stop, we need to heat the incinerator before we can put it into operation. We use biogas and oil for that. And of course we use the biogas for our own heating purposes of, for example, the digesters, which are operated at around 37-38 degrees centigrade. It's a fluid bed incinerator, and here we burn the sludge from this plant, the Lynetten wastewater treatment plant, but also from the Dammelsåens wastewater treatment plant. The capacity is around 2.35 tons of dry matter per hour.